Good morning, everybody. This is a talk about WDM, which is a technology to allow getting more capacity out of a single strand of dark fiber. And it's a continuation of our previous talk at the previous conference. But if you have missed that one, don't worry, we'll just cover what was missing, what we covered before. So, what is WDM and why is it good? WDM is really a solution to a problem of getting high-capacity transport over a short range or metro area network. Metro is really a distance of about 100 kilometers where you can use the technology without having to use amplifiers. How does WDM work? It is essentially sending multiple independent streams of data over one single mode fiber. Why WDM is very popular? Because the cost of dark fiber is fairly low. It is comparable to the cost of a single lead circuit, and the capacity of a dark fiber is essentially unlimited and it can scale up to based on the equipment that you put in to terminate this dark fiber. So you are not paying, if you scale from 2 gigabit to 10 gigabit to 20 gigabit, you are not paying more per month, you are paying more in equipment to terminate this link. This is the standard technologies you could use to use WDM. First, you can do wide wavelength division multiplexing. Basically, you have LX and ZX optics and two wavelengths. That gives you 2 gigabit of capacity. You can do the same thing with 10 gigabit Ethernet using LR and ER optics, and you get two 10 gigabit Ethernets. You can do coarse wavelength division multiplexing CWDM, which will give you 8 gigabit over the same fiber. Or you can do dense wave division multiplexing for 10 gig Ethernet, and you could get up to 64 10 gigabit channels. Why is WDM very interesting for somebody who has operational experience and trying to build a network on a low cost? Basically, you can grow this when you have a system which is GWDM, 2 channels. You can add more filters and extract more wavelengths and scale it up as you grow. This is an example of a filter setup for one of the configuration. First, we have 1310 1550 splitter. One end, the 1310 end goes to another splitter that extracts LX4 wavelengths, and as a result, you have two 10 gigabit channels and 8 gigabit channels over a single pair of fiber. So once you have reached the capacity of the standard system, how can you scale it to get even more? And this is the subject of this presentation. The more exotic and more advanced techniques how to get additional capacity. The one technology is LX4 and LR splitters. You can do you can add 10 gigabit channel using LX4 wavelengths. What is LX4? LX4 is actually by itself is WDM multiplexed 2.5 gigabit channels. There are 4 channels, and the useful thing is that it doesn't interfere with LR wavelengths. So you can use LX4 and LR over the same pair, and essentially you can get over the same pair 30 gigabits instead of 10 gigabit Ethernet. What is an interleaver? Interleaver, you can have It splits. I'm sorry. This old slide. Interlivers add capacity by essentially taking the two channels and splitting them based on even odd spacing. On even, for example, if you have a system with CWDM, the CWDM channel is approximately 2 nanometers wide. You can put it into two of those channels into the same interleaver, and you can extract one channel which has both data, and each of those is about half of the light level. What is a circulator? So circulator essentially uses polarization to transmit on the same wavelengths in both directions. So if you had a system that used two pairs of fiber, you can put the same system on a single strand of fiber, using the fact that polarization can be used to separate light going on a different directions on this fiber. So the caveats of doing this technology. To my knowledge, there is nobody doing commercial systems based on interleavers or LX4LR or circulators. So you are pretty much on your own as far as building a complete system. With certain technologies, for example, with circulators, you depend on the limited internal reflection of the fiber, and this is something that you don't have to worry when you're doing just single directional Ethernet. If the fiber of the splices have significant internal reflection, you may get your own signal reflected back, and you would get a link to itself, and then your port will get disabled because it will detect link. So you have to attenuate signal to prevent this from happening. Doing this configuration requires somewhat expensive equipment to test it and to get something useful out of it. The spectrum analyzer, the broadband light sources, all that stuff is not very cheap. And of course, what will happen if the engineer who built the system gets hit by a bus? Will somebody else know how the system works and how to maintain it? If it breaks, what do you do? So where do you get this stuff? There are a number of companies who produce optical components: AC, Avanex, E-Tech. The components itself, somewhat expensive, but the best place to buy, eBay. And there are a couple of companies who build components based on your specification. For example, LX4LR splitter. The company that made it for us is OE Market. If you have any questions, I guess you have to mail us or catch me at a lunch. Thank you.
Thank you.